Air leakage can be responsible for up to 40% of heat loss from buildings. This project instigated potential solutions for measuring this leakage.
The University of Nottingham started work on this project about 13 or 14 years ago as an internal project initially, which is when I came on board then for a PhD.
As the project progressed, the university teamed up with a consortium of partners who could assist in bringing a product to market.
NEF's primary aim is to improve the use of energy in buildings. We know that air leakage in buildings is a source of heat loss, and one of the ways we can improve the energy efficiency of buildings is to make them more airtight.
Elmhurst Energy would like to look at the commercialisation of this methodology, so really help University of Nottingham and the other partners taking this to the marketplace.
Due to the short pulse of air used, the solution devised by the university is called the pulse test. It is a highly efficient method of testing the airtightness of a building and produces instant test results.
NEF has a big interest in this technique because we believe it is faster and more accurate, more accessible to people, and that will benefit the quality of construction.
The concept behind the test relies on releasing a small volume of air into the building, which creates a subsequent pressure change in the building. We can relate that pressure change to the volumetric flow rate that was released into the building and plot it on a graph.
The pulse equalizes in the building at the speed of sound, so for a typical dwelling, we don't have to worry about the uneven pressure distribution.
The air tanks on the pulse unit are interchangeable. The 60-litre tank option is suitable for the majority of buildings, although there are also 40 and 80-litre tanks available. The low-noise motor drives a twin-cylinder compressor that then charges the air tanks within a matter of minutes. The pulse control box mounted to the unit contains everything required to conduct an accurate air tightness test and produce instantaneous results. The control box can store up to 100 test results internally, which can then be exported to a USB stick. A future enhancement will allow test results to be wirelessly uploaded to cloud-based evaluation software. The pulse unit is portable and can easily be operated by an individual. The pulse unit is wheeled into a ground floor room in the building. The pulse's digital control box is currently stowed separately from the hardware to avoid damage during transportation. Future units may include integrated controls, with the further option of controlling the test from a tablet or smartphone. Once on site, there is no need to pierce the building envelope to record external pressure. Instead, the internal pressure change is measured relative to the small reference pressure vessel. The control box is connected to a solenoid valve which controls the timed release of the air pulse into the building. The compressor can be switched on in order to charge the air tank, whilst the operative makes the necessary checks to the building fabric and prepares the building for the test. For instant results, the volume and surface area of the building can be input prior to undertaking the test, or, if not known, can be added later. These would normally be calculated from drawings, but it must be confirmed that they are current and accurate. The pulse test can now commence. The operative presses the Safe to Fire button and a short countdown commences. A pulse of air is released and the test result is instantly displayed on the pulse control box screen.
So the pulse test has significant advantages over the conventional methods. The test is very quick, it's literally of the order of a few seconds. It's at low pressures, so we're able to get measurements directly at the pressures that you find in normal use in a building. So we don't need to extrapolate down from the high pressures found in the blower door technique.
The pulse test is a highly efficient method for measuring air leakage from buildings. Simpler and more cost-effective than current techniques, it represents a big step forward.
In the wider context of new build construction, a cheaper, faster, easier test to carry out will enable multiple tests through the construction process, helping to improve the quality of the finished product.
The innovative pulse test was initially researched and developed over many years by the University of Nottingham. Now, with industry partners Elmhurst Energy, NEF and Absolute Air and Gas, the refined pulse test is being presented to the market. Pulse, preventing unintended leakage, saving energy.